Hey everybody, MC Infrared Riding Hood or Mark Poppinchock here. Just a quick note to say we're waiting a few more minutes for folks to show in, but hopefully you've all grabbed a drink by now and we'll be ready to start the show soon. Hello everyone.
Hey, it's me.
It's us. Hey, yo.
Irene, why are you wearing a mask?
My pizza guy's coming. I don't want to get the pizza guy sick.
Oh, fair enough.
Fair enough.
Are you kidding? Plus, it's my Marzi mask.
Oh, nice.
All right, but I'm just gonna do what my high school kids do and
Yeah. Is that the Mars necklace with the 2 meteorites?
it's a Mars necklace. Because
Yay!
aren't we doing Mars tonight?
We are
I
doing
think
Mars.
we are.
I got some
Mars.
Mars pins over here.
Mars, more Mars.
Woo!
And my name is Mark.
Mark. You win.
It's true. I've
Mark
always felt
wins.
very
God damn it.
connected to Mars. Partly because of my name. Yeah.
We should just call you Infrared Riding Mars.
We
Infrared
could do
Riding
that.
Mars.
It wouldn't nearly be as good. For everybody, thanks for joining us. We're just shooting some shit for a little bit while we wait till 8.
I'm
and
drinking.
then-
I don't know about you.
Oh, we're having some drinks as well. Of course, it's Astronomy on Tap. I hope everybody's pouring a drink. Let us know what you're drinking in the comments. Brian, what are you drinking today?
Oh, so my sister sent me this, or gave me this. Not sent. She lives upstairs. Where's my camera?
Big
There
commute.
it is. A
Ooh.
special Angry Orchard beer cider. She was at the cidery, extraterrestrial based cider,
Nice.
and it's huge too. I'm gonna have a fun time
Because
getting
aliens are huge.
well,
These
these ones
days.
are. No, these
Yeah.
ones are
Packaging
worms.
is
Like the
huge.
worms are there for scale. Where'd it go? See, it's not that.
Yeah. Okay.
Yeah.
Got it. Mark,
So
what do you
thank you.
have? What are you
Thank
drinking?
Me, I am not. It's just beer.
Just beer. It's never just beer, though,
It's never
really.
just beer. It is a Pilsner. Dry hopped
Nice.
Pilsner.
There you go.
It's got star stuff in it, so
Yes,
there you go.
exactly.
We all have star stuff in us, but
Yeah,
yeah. I mean, that
Mark didn't
beer
prepare
is
for
very
tonight. I'm trying to
starry.
help.
Yes.
Mark still wins.
Looks like we've got somebody drinking a Marsberry or cranberry cider. Actually, that's Sally Starrider, our friend of the show.
Oh, Frankie.
Awesome.
Cat, go get some booze.
Somebody else is drinking some scotch, which sounds a single malt scotch. Sounds very nice as well.
Nice.
Jim Beam and cream soda. Great.
Fred, what scotch are you drinking?
That counts.
I almost pulled out the. I've got an Ardbeg Supernova that I almost pulled out, but that cost a lot of money, so I didn't.
Come on, it's Astronomy on Tap. Go all out.
Good
all
humble brag
out.
there, Brian. Nice.
I've been working my way through the scotches that I don't know. I guess the right word is hoarded before the pandemic. I haven't bought a bottle of liquor in a while. It's
nice.
One nice thing about this.
That's good. That's good.
Yeah.
Oh,
I was doing
while
an
you're
awful
waiting,
lot of wine for a while, but I've slowed down. So, yeah.
Just like the rover needs to tomorrow.
Hey.
Nice segue.
Thank you. But while you're waiting and just listening to us talk about absolutely nothing.
Oh, sorry. This is my pizza.
Oh.
Stop interrupting the segue.
Well, tip your bartender and your pizza guy, but also go to bit.ly/AOTNYC Feb21. The link is also in the chat for the game card for tonight's game. You don't have to finish it until the break is over. So we'll have, I think we have 2 talks before the break, I think, right, Mark?
We do.
So
about till 9 o'clock.
Yeah, about nine-ish.
So
give or take.
What are the games, Brian?
The games, well, the one that's scrolling right now is a set of 9 pictures. And I would like you to tell us if you think they are Mars or Earth. And it's just a simple multiple choice, one or the other.
Brian, I have a fun story about this game. This was
okay.
first Astronomy on Tap that I ever went to. I was not a host, which makes sense. I was a bushy-tailed, bleary-eyed little audience member, and I was pretty fresh to New York. And I came to this event, and I was so starting because this is part of a game that we had in at this previous event,
2014 at the World Science Festival. Yeah,
and I was certain that I got every single one right, and I thought I was going to win a prize, and I did terribly.
That's usually what happens on these quizzes. No one does wonderfully on them.
This one's a challenge, though. You think you can tell the difference between Earth and Mars, but it's tough.
Yeah, I got another story about that one later too. So remind me when we get to it.
I will, Brian.
And so the second game, which the instructions are coming up in another minute or two. It's on the same game card, same exact link. We are looking for the next technology to get to Mars because we're landing some stuff there tomorrow, at least if everything goes right. Break a leg.
When everything goes right.
When everything goes right. And some of these things have really kind of fun and acronyms. Some of them are terrible acronyms. So we want to know what technology you would send to Mars next and what terrible acronym it could have. Now, this could be anything. You might want a coffee maker up there. There we go. There's the acronym game. So we got a helicopter tomorrow. So what should be next? Is it a water purifier? Is it a pinball game? Is it a pizza guy? I don't know. Whatever you think should be. Is that a technology? I don't know.
We'll give you some examples.
I might have some lined up for examples.
Oh. Irene's got some also. That's a surprise.
Oh, that's
Mark
right.
And I lined up.
No, mine are real. I didn't get creative.
Yes.
That's where my brain is.
So actually, Irene, I think I need to switch PowerPoints because it is past.
We want to get started? Okay. Well, while Brian's bringing up the intro slides, first of all, we'd like to say welcome everybody to Astronomy on Tap, NYC. Of course, you might not be viewing us from NYC, but it's always useful for us to know if this is your first Astronomy on Tap or not. So if this is your first Astronomy on Tap, go ahead and let us know in the comments, because that's kind of interesting to us.
We do have a first time listener, lifelong astronomy lover and stargazer. So
wow,
welcome.
we can do
awesome
live comments like this.
Yes. Welcome to StreamYard, Mark.
This is why Irene is running the production tonight.
This is why I'm just gonna sit back and eat my pizza and just interrupt everything. It's all good. It's all good.
Awesome.
Awesome. We got Kelly Cruz is here.
Hey, Kelly.
Oh, my advisor.
This is a graded exam then.
Yeah.
Kuiper Cat. I think Cat, actually, I owe you. I kind of put the prizes from last time away to do something with. I think I might owe you one of those, so expect an email. Yes. But we have some prizes for tonight, too. I got a couple of Mars stickers and a little Mars, not Mars. These aren't Mars stickers either. These are NASA stickers.
Those are meatballs.
Yeah, meatball stickers. An Explore Mars sticker from a couple of years ago, so it doesn't have Perseverance, but it has
the meatball on it.
It has the meatball. And since it's nice and flat and it'll fit in an envelope, space shuttle launcher flight thingy. So, Irene, can we share Can we share my screen?
Oh, of course.
Because we want to welcome you, as Mark started to do, to Astronomy on Tap, New York City, part of the larger Astronomy on Tap network around the world, with over 1,000 fucking shows that we've ever put on.
Wow.
This is no, not New York. That's
no, not New York. New York,
around the world.
We're the longest living.
We're the originals.
We're the originals. This is Astronomy on Tap exists on almost every continent.
Have they done it in Antarctica yet? I feel like they're all scientists down there. They should.
Could, honestly, but
there's Ice Cube and other, astronomy.
Anyway, you're here at Astronomy on Tap NYC.
Yep. And this quarter, I guess we've been kind of doing them quarterly during the pandemic. We are concentrating on robots on Mars because there's some exciting things happening last week and this week. So yeah, already kind of mentioned them. We got 2 games going on. We got prizes, so you don't have to have finished that yet. You can work on it while we're blahing away here.
But again, the link is the pinned comment in the Facebook Live event. So please go ahead and fill out the form. We'll show you the clues for the game again during the break. And you have to guess whether it's Earth or Mars. And then the fun one is write an acronym for a mission you want to come up with. We'd love to see some creative answers.
And if you need some inspiration for that, here's some acronym examples. I was thinking you could send the Spout, the Spirit Procurement of Off-World Straight-Up Tinctures, which is a drill system looking, of course, for booze on Mars. Get it?
Very
Spout.
Good. Very good.
And Clink, the container for linking and imbibing during nightly keggers, which is, of course, a sample distribution solution from a fermentation experiment. Basically a beer mug.
Mark, space beer mug.
Well, they say the science case is only as good as the acronym that can come out.
Well, I have to say there's been a lot of really good acronyms that have come out of this pandemic.
True.
Like really, like all the beer that people have been drinking at home, all the day drinking, it paid off.
Good. But this brings me to I was looking around for goofy stuff about Mars earlier today, and I found this advertisement from 1893. Which there's a new telescope, and this soap company was like, let's go in on the Mars hype, and Mars is peopled and they want soap. So my mission would be Suds sending useful detergent space words. This is a real advertisement. Anyway,
I love how they're using like astronomy and science to sell stuff. Like today's like sex sells. It's like, hey, you know what? Science sells too. So take that.
Giant telescopes.
Giant telescope. Yerkes telescope. Biggest refractor.
I have been there actually.
But we have this is not a real mission to Mars, but we do have the first of our speakers is talking about our missions on Mars. It's actually Irene.
Oh, Irene, it's me.
You cheater! You're both a host and a presenter.
Holy shit. Okay.
Oh, yep. Gosh.
I only have.
I had a host slide too, didn't I?
Anyway, yes, but we have 3 amazing speakers. One of them is Irene, who you've met. We've also got Micah and Dan coming up later, and so you'll hear about their talks. But we've got a really cool lineup all about Mars and the missions to it, because tomorrow is the landing of Perseverance.
It's another one.
And for some reason,
stealing my thunder.
I skipped the slide where we all introduce each other. That, or I'm already drunk and forgot. But hi, I'm Brian Levine, sometimes known as MC Tycho, and these are my co-hosts. Them.
I'm Irene P., sometimes known as a friendly neighborhood astronomer. And we all know Mark.
My name is Mark Poppenshock. I'm Infrared Riding Hood. And today is special for me because we're talking about Mars, which is the root of my name. And so I feel a huge affinity towards this planet. And whenever we talk about it, I almost feel like something comes over me. You know, the spirit of Mars comes through me. So I'm excited to hear our talks. That might come back later. Who knows?
I'm on the edge of my seat because I'm waiting for Mark to like turn into the rover or do something really wild. And I'm just.
Ooh, is it a filter?
We'll find out. All right.
Gosh. Okay. The suspense.
But
Mark
our
promised
first
a surprise.
Speaker, we have an introduction. That's right. Even though
you don't have to read it. I could just be like, I'm Irene. This is my wine. Here's some Mars stuff.
Okay. Very good. Then please, everybody, our first speaker tonight, drinking wine, talking Mars stuff, is Irene Pease.
Woo!
Great. Thanks for that beautiful introduction. So I couldn't decide between slides and NASA Eyes on the Solar System. So we're going to do a little bit of both because there's some really cute. Anyway, I should just get started. So I'm going to share a screen, hopefully just the one for now. NASA. So we're starting off with NASA Eyes on the Solar System. Really fantastic. You can download it for free at NASA Eyes. A lot of fun things. But here we're kind of like looking at an overview of Mars, right? So Mars is this planet. I haven't been drinking that much, I swear. This planet that's completely inhabited by robots, which kind of blows my mind. Is like, wow, we're absolutely living in the future. So even if we were just like out here kind of scrolling around Mars in like 3 space, we can see all this stuff around it. So there's like Deimos and Phobos. Those are its moons, right? Those are like natural satellites. And then there's all this other shit. Like, look at that. Like and there's another one on its way about to attack. So Mars, robot planet. Right. So first we have robots in the skies, right? So we have 6. Well, before last week we had 6. Now we have 8. And I'm just going to kind of pick through these in a little bit of order. So the one that's been there the longest is Mars Odyssey. And yes, these are all actually there right now. Mars Odyssey arrived almost 2 decades ago. And that one actually came out of the U of A, I believe, my alma mater. So Odyssey has been zipping around. Hopefully it'll still get renewed. It's doing a whole bunch of, imaging. So mostly they're imaging. That's a lot of what they're doing. It did a lot of mapping. This is actually orbiting at about the same altitude that the International Space Station orbits the Earth. So go Mars Odyssey. I think they called it Odyssey because it was 2001. So get it like Mars 2001 Odyssey. Yeah. Anyway, so there's Odyssey that's roving around, and then that can't be right. Mars Express was the next one. So that was an ESA mission, and Express it was like one of the fastest ones to get to Mars because it went when there was like a really, really close pass. So you have these like kind of launch windows when Mars is close, and then everyone sends shit to Mars, which is why there's like 3 things getting there right now, because there were like 3 things launched 6 months ago. Mars Express has like these weird spiky things, these huge magnetometers. So, magnetic fields, other fun things. It also makes like really close passes and then gets really far away. And I think that one was actually supposed to have a landing component that didn't quite happen. But that's cool, next time. And actually, the thing that was supposed to land is landing about where the Chinese might be landing this time around in Acidus Planitia. So, yay! Mars Express.
The Beagle or something like that, right?
Yeah, the little hard landing. So, planning for a soft landing tomorrow. All about the soft landings, not so hard, more soft.
Irene, I'm sorry, I had to jump away for a second. Are we just looking at solely NASA missions in this visualization?
These are all the missions. So it says NASA Eyes, but there's other stuff that's not NASA. So MRO is mostly NASA. That one is going to provide a lot of the data that Micah's going to be sharing with us later. So HiRISE CTX, I'll let Micah tell you all about that shit. Basically, this thing has a massive telescope on it that stares down, is like creeping on Mars, and well, creepy, but awesome because it makes really beautiful maps. So MRO has been there. And most of these are in polar orbit so that they pass like over the planet as it spins, so they get a view of the whole thing. So that's why they're zipping around in kind of these obscure-ish.
So each pass, they only see like one line, but each time, the next time they come, the planet has rotated underneath, so they're seeing a different line.
Exactly. So we get like these kind of north-south strips of data. And again, we might see some of that in open space because Mike is awesome. So the next one that got out there just in the last decade, like it's kind of exploded. So there's one that's MOM. I think it's way out here somewhere. MOM, the Mars Orbiter mission. That was the first ISRO mission. So the Indian space research organization,
cool.
They basically sent that out there. So most of these, again, are looking at the atmosphere, looking at how the solar wind interacts with Mars's atmosphere, because that's like a big thing. Yeah, we want awesome maps of Mars, so we know where to send the next landers and things, but also we want to know about, potential habitability. So like, is the solar radiation going to kill us? Yes, no, maybe. So far it's yes and maybe. MAVEN was also sent out the same time as MOM. MAVEN, I want to say that's NASA-ish. So MAVEN's the Mars Atmospheric and Volatile Evolution. That's not MAVEN. Rock. That's a rock. That's a moon.
Irene, I don't know if you know it off the top of your head, because there's a lot of missions we're looking at, but how long is an orbit around Mars for some of these missions?
Yeah, so for the low,
that was one of the questions from the comments. So please.
Oh yeah, great question. So the further out ones are going to be like a couple days. So these close-in ones, I mean, again, the gravity is different. So with MRO being at about the same altitude as the space station, I would guess, yeah, a couple hours maybe, just a little. So maybe, yeah, several hours for the close-in ones. I actually have para-Aryan and apo-Aryan for all of them. So the close and far points in their orbit. So Earth goes through perigee, apogee. The moon goes through perigee, apogee. Earth goes through perihelion, aphelion. But for things that are orbiting Mars, they have a different suffix. It's para-Aryan, apo-Aryan. So
peri means close and api means far?
Exactly. Peri is the close point. And most of these are, somewhat elliptical. So you can just kind of zoom out and we'll just play through time.
Irene, what does elliptical mean?
I don't... All the hard questions, Mark. That's great. Because, so some of these are more circular. So the ones that are closer in, like MRO, the Mars Reconnaissance Orbiter, that one is fairly circular. But then a lot of these get further out. So the ones that get really close in and then far out, that's more of an ellipse. So I'm not going to say it's an oval because the mathematicians will start throwing shit at me. Nice. So don't do that. But it's like a stretched circle. So it has two centers. It has two foci instead of one center. So you can see like MAVEN there is zipping around in an ellipse. And then MRO and Odyssey are closer, more circular orbits. Wow, so the more highly elliptical, the further away it gets, and then it gets in a lot closer. So there's a lot of shit orbiting Mars. And there's actually shit on Mars too. Not a lot of shit, but a little bit. And not like shit, but like cool stuff, I should say. Right. So I'm not trying to diss it. It's just astronomy on tap. So like all the stuff that I hold in at the high school, it all comes out here. So I mentioned MAVEN. We also have ExoMars. That's a recent one. That's mostly looking at that was also supposed to have a lander in Schiaparelli. Oops, but they're sending another one. So ExoMars was basically like a exobiology or astroastronomy mission. So like looking for life and like these like methane, which is a biomarker, which means it's indicative of something that might be caused by living organisms. So it doesn't mean that there is life just because there's methane, but it, you know, it could also be caused by geologic mechanisms. But it's something that we look for as like, oh, we know that life produces this. So if we see it, there's maybe there's life, but doesn't mean that there is. So I'm going to pop over to, I'm going to stop this screen share.
Well, I guess the question is this eyes? Did you mention that this is like, where can other people access this?
Yes. Yeah. So I mentioned this is free. If you go to NASA Eyes, they have eyes on the solar system and they have eyes on exoplanets. They have eyes on something else. I think they have a lot of eyes. It's not creepy. It's cool. It's amazing. There's the website in the comments.
Nice.
So it's free and it's really easy to, you know, just zoom around and you click on stuff and it goes there. It's pretty intuitive. You can go through time. Very fun.
It's fantastic software. Yeah.
Cool.
So I am going to share just a little bit more because we haven't even talked about the fun things that are happening last week and this week.
Oh, right. The more recent.
Oh yeah, there's more Mars.
More Mars.
More Mars. All right. So the stuff that's on Mars now.
And I mean, you're not going to show all 29 of these slides, right?
No. So most of these were the orbiters, and I just like did that in NASA Eyes. So you're welcome. Cool. All right. So this is after the orbiters. We have two things that are actually on there now. InSight, which you can follow on Twitter and Instagram, obviously. So InSight was trying to probe the planet and in a totally non-creepy way, but it partially succeeded. It also sent CubeSats. So CubeSats work and they're great for communication because how do you communicate with all the fun, cool stuff that you send to Mars? Well, yeah, there's all these orbiters, but anyway, the CubeSats are like your own communication device. So it like tested those out. Landing on Mars, as we'll see, is a pain in the ass. InSight was lightweight enough. It just used a parachute and jets. It didn't need the freaking sky crane because, oh my God, it's not like literally a ton like some people, some robots, I should say. So InSight
sky crane was also because it had wheels and it was landing on. You know, you could just put the little like landers on these things.
Yeah, so it had.
We got a guy we can ask about that later, though.
Yes.
So there's.
I do have to say, I just there's already been a call in the comments to pour one out for Opportunity. So please, everybody, if you'd like to finish your drink, I just finished mine. I got to go grab a refill. For Opportunity, everybody.
For Opportunity.
For Opportunity.
Pour it out, I'm gonna drink.
They were like almost all of these missions were expected or projected to last maybe a year or two. But they all lasted. They've almost all like far outlasted their initial mission time.
The old Spirit and Opportunity were only supposed to last 90 days, I believe.
Yeah, it's like years and years. Years later, we're like, oh, finally bit the dust. But InSight is recent, just in the last 2 years or so. First seismograph, like of all the stuff that we sent to Mars, this is the first like earthquake detector. So it's found a bunch of earthquakes. And then it was also supposed to drill down and do like a temperature profile with this HP3 thing. That didn't go so well, but we still learned a lot. It has earthquakes or it has Mars quakes, but they're really little. And anyway, MSL has been there the longest of all the rovers. Well, there's only one rover and one lander right now. So it's the only lonely rover and it desperately needs some friends and help is on the way. So it's been there for like almost a decade now. The EDL, I'll let someone else talk about the EDL because the entry, descent, landing sequence is the same as what we're anticipating for tomorrow. No, it didn't find a friend to take the selfie. It has an arm that moves around, so it takes its own selfies. Cute little bugger. Skip that. It does have a couple cute acronyms. Sorry, I forgot to mention some of the other acronyms on all the other orbiters. There's some good ones. But here we have Sam and Dan. Sam's the sample analysis on Mars. Dan is one of the radiation detectors. So Rad and Dan are your radiation detectors.
Rad.
We also has a dust removal tool, just for tidying up around the place, like you do.
I need one of those. Dang.
Isn't that cute? Oh, okay. But and it found blueberries. All right, so there's the highlights. It has a dust. It cleans up after itself, and it found blueberries on Mars. It's been roving quite a bit And there's this really great website. I'll just post this in the chat. So if you want to know where is Curiosity now, you can find it at the Where's the Rover website. And I'm assuming they'll make a second one for Perseverance. Oops.
We have another question about how long it takes the signals from the probes to reach back to Earth. We can also, do you have that number off the top of your head, or we can pass it?
I do, yeah, because Mars is going to be on average maybe 4 light minutes further from the sun than us. So it's going to be basically 8 minutes plus or minus 4.
So, and the reason it's 8 minutes plus or minus 4, is that like a round trip there and back, or is it?
That's one way. So if we're close to each other, it would be closer to 4 minutes. If we're, I just lied. It's going to be a lot further than that. If Mars is on the far side, it's going to be 8 minutes and another 8 minutes and then another 4. So if I'm doing my math right, it would be like between 4 and 20.
Cool. I'm sure we'll have Dan in here will be able to tell us.
But that also depends if the message is going straight from orbit. So it might have to be saved until an orbiter actually passes overhead.
Right. And so that was why one of the InSight actually brought the CubeSats. So because MRO is fabulous, but it doesn't download and upload simultaneously. So the CubeSat things, the Marcos, they called them, almost like Mark, but not quite so close. They were able to communicate like basically instantaneously with InSight. So we knew like right away that InSight was there. Because otherwise you have to coordinate with one of the orbiters. But you have like 5 of them that are active and doing that kind of stuff right now. So,
Good.
So Hope, recent arrival. Woo! New country. Woo! So that's the first UAE expedition, and they made it, and they're in orbit, and they're adjusting their orbit, and they have 3 cute little probes, cute little instruments. My favorites. So 2 really great acronyms. They have EMUs, EMUS, and EMERS, right? So EMUs and EMERS, orbiting Mars. Super awesome. Basically looking at the atmosphere, like everything you could possibly want to know about the atmosphere. That's what Hope is working on. 10-1, in orbit around Mars, planning to land. And I know someone else is going to talk more about the potential landing sites. They're still hoping to land in May. So they're going to be narrowing down the candidates and hoping for a successful May landing. And they're going to do something similar to what they did on the moon. So remember, the Chinese just landed on the far side of the moon not too long ago, and they did a sample return for the moon. So Chang'e 4, Chang'e 5. So they do the little thing that lands, and then it like opens like a lotus, and then it rolls down the ramp all cute like, and then it rolls around. So it has like some ground penetrating radar and other cool stuff. So it'll be a rover and a lander and an orbiter. So looking at some of the same aspects of Mars, including the magnetic field from both sides. And then, of course, Mars 2020, which should be getting there. I don't know. When is that? When does it get? Tomorrow? Tomorrow. So follow
like elementary school. Mom, I've got a project.
Oh my God. Holy shit. That's tomorrow. Oh my God. I forgot my homework.
Oh, okay. Don't worry. Somebody who's thought about that.
Did you pack your pencils?
Somebody who has thought about that a lot is going to be talking later.
So yeah, I'll let them talk about more. So Jezero Crater, which we may or may not see in open space. So that's apparently what it looks like in space. It's huge. Like these are people. Here's like the huge capsule. And
drop on them.
Looking for habitable conditions and past microbial life. So some super cute acronyms on that. 1, MOXIE. So Brian mentioned like a water maker. This is an oxygen maker. I guess proof of concept. But yeah, MOXIE is your oxygen maker. And then we have
literally for like terraforming experiments.
No, I don't think it's for terraforming. I think it's for human use potentially. Oh, okay. I don't think they're expecting this one little dude to terraform, but it's like proof of concept. So turning CO2 into O2.
Yeah, it's literally taking atmosphere and turning it into breathable oxygen.
That's nuts.
That's right. MOXIE. MOXIE.
You're right. That's not nuts. That's MOXIE.
Right.
All right.
And I don't know if anyone else can pick up any other cute acronyms here. Some are kind of a reach, I think.
Sherlock and Watson, that's pretty
seriously fun. Yeah, so Sherlock actually stands for something. It's a spectrograph. It's a UV spectrograph, and Watson is a camera. I didn't even know what that stood for, but Sherlock and Watson, and then Pixel's kind of cute, but I think Sherlock and Watson kind of take the cake.
There it is.
So
nice. Do you have anything more about the coring drill, or is there a good story that I need to tell about that?
You could tell about yeah, I don't have about the coring drill. I just have the helicopter. That's all.
It was made in fucking Brooklyn.
The coring drill was made in fucking Brooklyn, y'all. Woo!
Yeah, it's made at Honeybee Robotics. Honeybee Robotics has been making some of the attachments on the Mars rovers for years, and they are in the Navy Yard. So a piece of Brooklyn is on
screwing Mars.
Is going to be screwing Mars tomorrow.
Maybe not tomorrow. We'll
go
on a couple days first. We'll get there. We'll get there.
Has to romance its way in first.
A note from Dan, who works at JPL, saying that it's currently 12 minutes the signal going back from Mars.
So yeah, so they're not. It's not far side, but it's out there. Yeah, and then the only other thing I had is a helicopter. That's all.
Just a helicopter?
We're sending a fucking helicopter to Mars. Oh my God. Okay, so mostly proof of concept again. So it's going to do all these test flights and stuff. You can read all about it, but there's going to be a helicopter on Mars. Like, I could just explode, and I might. But yeah, so a lot of stuff happening on Mars. This is all the stuff that's on Mars and active or in orbit around Mars right now. This is the planet inhabited by robot. And there's a whole bunch of dead stuff there. All the dead robots that are like no longer operating. I shouldn't say dead robots, but the no longer operating robots. These are just the active ones, and this one's getting there tomorrow. Right?
But just to be clear, the sudden shut off on all those 7 near the bottom.
These are going to keep going. I had to make these bigger so you could see them. So these are just this month, and then these should continue. Most of these will continue.
We're turning them all
Sorry,
off.
that does look weird. It's like, screw you guys, we're taking over. We got this covered.
Due to the pandemic, we've had to shut down all the previous Mars.
We don't need to mention the pandemic
to Mars.
There's more comedy than pandemic. Anyway, this is super cool. I think we do have to start to transition, but I want to see if I want to give a couple minutes for questions for people to have. If any people have them, throw them in the comments. Maybe we'll be able to handle them. But Irene, I guess one of my questions is, which of these missions that are currently around Mars is your favorite?
Okay, I guess I have to be partial to MRO just because I love flying around that data in open space, and I'm a huge open space fan.
Remind me which one MRO was?
So MRO is the Mars Reconnaissance Orbiter. It's been there not quite the longest, not as long as Odyssey and Express, but it's freaking huge, and it basically has a telescope attached to it. Like it's a decent sized telescope that's attached and staring down at Mars, getting this super amazing data that Michael will probably tell us all about.
Nice.
Yeah.
Micah will use too.
Yeah. And I also want to say, a lot of the stuff that I put together is for a AAA class. So if you want to learn more about this kind of shit, you can join AAA. AAA, I'm so glad you asked. It's the Amateur Astronomers Association of New York. And we have classes and, stuff, observing when it's not, Ronaville, and lectures that are free and open to the public. So it's a hoot. If you like doing astronomy, and we don't drink as much as Astronomy on Tap, at least not as a group, officially. But it's a hoot. And I also do some live streams on Thursday nights that I think are in the slides. So I've been doing a lot of Mars lately. So it's been Mars. Lots of Mars.
Nice.
Yeah.
All right, I've got 2 questions. One of them is, what's the biggest thing thank you, Chris, for asking, what's the biggest thing which has been sent / are sending to Mars to date?
Biggest? So I think the MSLs, the Mars Science Laboratory, so Curiosity and Perseverance is the same class. So it's going to look a lot like it, but it's going to have some of that extra stuff. Those are the most massive things to land on Mars. That's why you need that extra freaking sky crane to land it safely. As far as, I actually have a scale image, so I can show this real quick, of the things that have been sent in the past. There's a beautiful website. This guy has, let me just find it in here, all kinds of these. So historicspacecraft.com, Richard Cruz, he has them for like the Apollo landings and like the space shuttle, like all kinds of really, really cool. So these are all like scaled images. So MRO is pretty freaking huge. Viking apparently was big. Viking went by. That's a little person. I don't know if you can see this little astronaut person just for scale, but of all the landers, like MSL is the biggest. So you can see they've kind of grown. Maven's kind of big, but I would just go MRO. I don't know mass wise, but here's some scale sizes of them.
There's that great picture of Carl Sagan standing next to the Viking.
Next to Voyager.
What's up?
Next to Voyager.
Next to Viking. But it's not the real one. Clearly, it's a model of it. I can't remember the engineering model or one of those. It has a name.
Nice.
Some of these, like I didn't realize how huge they were, and I saw like some of the image of them, with people working on in the bunny suits that you do, like in the clean rooms and stuff. Even when there's not a pandemic, and I'm like, those are freaking huge. Like I had no idea MRO was so huge.
Cool. Nice. We have a couple other really good questions here. I want to welcome Dwayne Lee. I haven't seen him in a while. He was one of the original Astronomy on Tappers. He definitely presented in one of like the very first ones years ago.
Nice.
He wants to know, Irene, what you think the mission with the most impactful findings is.
Oh, wow. I don't know if I'm a good person to answer that. And I mean, I guess Odyssey, maybe. Well, as far as anything that's gone past Mars, it hasn't gone. Yeah, the most impactful missions I would say are the Voyagers, because they found things that no other mission has even touched. Like they're still like the singular missions to the outer planets, to the ice giants. Yeah, I don't know as much about the early missions because I haven't been studying them, but of the ones that are currently there, I would have to say Odyssey. It's been there the longest. It did a lot of groundbreaking things. And that between that and MRO, because they also found landing sites for future missions like Insight and Perseverance and everything. So they've been doing like a ton of work, and it's like not a lot of people know about them. They don't follow them on, Facebook and Twitter and stuff. But, they're like, oh, there's a rover taking selfies, which is awesome. And it has lasers and a drill. That's awesome. But it's probing around like one region up close and personal, but like the global maps, we have amazing, amazing global maps, and not just visual.
Is that a good
Speaking
segue?
of.
Yes, it is. So let's take this opportunity to thank Irene for giving us an amazing overview of some of the missions, current ones and past ones that exist on Mars. So Irene, thank you so much for doing
so welcome. Thanks for letting me geek out. I've been gushing Mars.
Now you can eat that pizza too.
Yeah, now I can eat my pizza.
Enjoy some pizza for a moment if you can. But the spirit of Mars is just flowing through me.
I don't know. There's opportunities on Mars too.
Yes.
Persevere, Mark. Persevere.
Persevere. I'll try and persevere. Brian, what are we going to see next about Mars?
What? That's a. I don't quite know everything we're going to see. That's a big question mark.
Brian, what presenter is next?
I would love to welcome to the stage Micah Achapanura. I think I'm saying that's roughly correct. Achapanura. It is Cha. Yeah, Achapanura.
Yeah, pretend there's an H in there.
Yeah. Okay. Micah is the oh crap! I meant to look it up and still haven't remembered. But he's the mostly the flight director for the Orbitron 6000 or whatever it is. No, Micah's he works at the American Museum of Natural History as a software developer for the Open Space Project, which I'm sure he's going to tell us a lot more about. Or do you want me to, Micah?
No, I can tell. Okay. Yeah, I'll talk a little bit about when we first start.
Cool guy, Stuyvesant High School graduate, native New Yorker, collects stickers. I don't know what else. He looks like he's in his parents' house right now.
Yeah.
But yeah, Micah, welcome.
Thanks. Yeah, glad to be here. Yeah, New York, Astronomy on Tap. I've long time been a space enthusiast, but like only recently become in this whole space world. So.
Long time caller, first time. No, sorry, long time listener, first time caller.
Third time presenter.
Definitely the owner of the hat, which I am most envious of.
So. Wow, yeah. So I actually wound up. I got this hat before I started working, or I guess before NASA paid my salary. I don't work for them. I work for the museum. But like now it's like become my most prized hat, and people try to trade me for it everywhere I go. People trade me hats, dinners. They offer me money. It's like I paid $7 for this hat, the best deal ever, and it was $5 in shipping. It was $2.50 for the hat and $5 in shipping. So
links in the comments.
Wow.
Yeah, right.
Yeah,
Shout out KYC Vintage. Nice.
Sorry, since I mentioned Stuyvesant 99 to my sisters in the audience, Micah, a classmate of his, although they did not know each other.
Yeah, well, we had
Small-
one of the
small-
biggest high schools in the city.
Big high school, itty bitty escalators.
Yeah. But you know, it's nice when you find all these connections, you know. And I went to my college I went to was smaller than my high school, and yet some of the pictures that were taken, one of the guys who worked on the camera is a graduate of my small college in the middle of Indiana.
Nice.
So who know, you know, you never know how that's going to happen.
It's a small world.
Speaking of
Sorry,
Not
now
as
we gotta
small
play
as
royalties.
Mars.
Speaking of small worlds,
Yeah.
Micah, what are you going to show us about Mars?
So
Can I go
I'm
to
going to
Aggie?
show us some of the coolest stuff about Mars that we can see, basically. And yeah, Mars is a small world in that it's half the size of Earth, I think, something like that. And so I'm basically going to show you all the best pictures of Mars that we can and all the best views that we can. And these views are all coming from these orbiters that Irene was talking about. So I'll just start out by saying that what we're looking at is open space, and this is a software that I work on at the Museum of Natural History, and we got a grant from NASA to work on this software.
That's not,
And
a grant. That's a fucking huge grant from NASA.
yeah, I guess it was one of the biggest grants the museum has ever gotten. And so, you know, it's a pretty awesome project, and we work with both, you know, our scientists at the museum and with computer scientists around the world, and NASA people. So it's, you know, this whole project is about visualizing the whole entire universe, but today we're just going to be looking at Mars, and we're going to be using some of these amazing maps of Mars that were created with images from these orbiters and things that were going around that Irene mentioned. So the most you know, important one to me, so to speak, is the Mars Reconnaissance Orbiter, and that's because it has these great cameras that took these close-up pictures. So what we're seeing right now are these high-rise images, and that stands for high resolution something. And it's basically the closest pictures we have of Mars from something in space. So we have some other closer pictures from things we've landed. But these pictures are 25 centimeter per pixel resolution, which, you know, means I used to say something about the size of a laptop. If there was something about the size of a laptop on there, you would see it. But I heard Irene the other day say something the size of a cat, and I like that. I thought that was fun. So maybe like a small dog or something. I'll say, I don't know.
Oh.
But
So
you
you'd
know,
definitely be able to see a husky then, or something like that.
yeah, exactly. And you know, I heard someone say once that if Matt Damon was there, we would see him. So
True. Yeah.
you know, I actually when I talk about this with some people, sometimes they ask me like, "Oh, have you ever found any alien stuff in the pictures? You know, when you're flying around and looking at them?" And I say that no, but if it was there, we would see it because we have good enough resolution. But it turns out no, we haven't seen any. And as you see later, I can show how much of the planet I have mapped in this high resolution, and it's enough that if there was something there, we would have seen it.
So, but Micah, again, we're looking at real data here from Mars.
Yeah.
25 centimeter resolution.
Yeah.
That you're flying around in real time?
Yeah, so I'm flying around in real time, and this is Mars right now, but it's not, and I'm flying in real time, but this is not a live picture of Mars. So one thing that's always important to like tell people is that I'm not seeing a live stream of Mars, right? And I'm, you know, sometimes we post a video and people say that can't be real. How did you fly there? And I say, well, you're right. It's not real, but it's a real picture. And this is not a real video from a live stream of a helicopter. But what we've done is we've taken the pictures from the orbiter, and so I'll zoom away from this one a little bit, so you can see that we've taken them and we've taken the pictures and put them into a global map where, if you think a map is really just a picture with geographic information added to it. And so
it's fucking Google Earth for Mars, but better.
Yeah, it really is. And it's not
so
that
all he's doing at people is just he's on a website and he's zooming in and out of Google.
Brian, way to shit on our presenter.
Yeah, no, I mean, actually, they do have Mars in Google Earth.
No, they
do.
You
don't actually get all the same data sets. And when I say data sets, I mean the different imagery that come from the different orbiters, right? And so here you can see those strips that Irene was talking about. And so I'll pull away and give us a little detail of what these strips are. So the strips are the highest resolution we can see, and that comes from the Mars Reconnaissance Orbiter HiRISE camera. And then what you see outside of the strips is a map that comes from the CTX camera, and CTX stands for context. And that's actually about 6 meters per pixel resolution. So that's, about something like a little smaller than a house or a small garage. And so we have basically the whole entire planet mapped in that in that lower or medium resolution. And then we have these little strips in that super high resolution. So if you remember, we were flying around in that area, and it looked pretty cool and it looked pretty big. But if I kind of zoom away and give us a global view, we mentioned global maps of Mars. So I'm actually going to pull out and give us a more global view. And as I pull out, just look at that little strip and start to think about how big it looked when we were flying in there and how small it looks when we zoom out from Mars. And so this map that you're seeing right now, this global map, is from the context camera, but maybe I can turn that off and we can see a different map that comes from the wide angle camera. I could also...
While you're doing that, also, Corey is actually in the chat answering some open space questions. She's one of Micah's colleagues. And this is downloadable software, so I'll put that in the chat as well. And she linked to the Facebook page, which I think also has the link to that.
So this is all actually free open source, and everything I've showed you so far is just in there, and you can browse around yourself and fly around. I have added a few things in that we'll see later that I just downloaded and added into the folder on my computer, but pretty much almost everything you're going to see, you could explore yourself at home.
You can drive your own Orbitron 8000.
Yeah, so we mentioned the Viking mission, and that was a really important and famous mission. And so here's the map created by the Viking mission. And even though we have better map, and I put the quotes there, we still use this one today, because even though some maps have better resolution than others have different looks to them and different lighting, and were taken with different instruments. And so at certain angles and certain distances, we like to use one map, and at certain distances, we like to use another map. So this one is the Viking one. So I'm going to take us actually down to one of my favorite places. And this is actually one of the first places I saw in the high resolution.
Micah, I have a question for you.
Yeah.
Do you know the geography of Mars better than you do the geography of Earth at this point?
Yeah, actually, which I guess is kind of a funny thing to say, but there's more. I mean, how do I put it? I know the continents and stuff of Earth very well, but there's more locations on Mars that if you said fly me there from space, and I could fly you there to where we landed the rover or something. But if you said fly me to the city in South Africa, I know where South Africa is, but I wouldn't be able to fly you to that city.
Fair enough. So what are we flying into right now?
So this is called the Light Tones Mound in Ganges Chasma, or Chasma. So to be honest, I've been learning about planetary geology as I go, as I've been working on this software and viewing the maps and browsing them and incorporating them and downloading all the data. But I actually can't tell you too much about how these were formed and what they're made of. But the really interesting thing is the look of them. And you're going to see we have this higher resolution data is coming in for this square here. And what's really cool is you have these kind of mountains in the middle of this flat area. It's like, surrounded by, it's like in a canyon, but you have these three things sticking out. And what's really cool is you can kind of see how the wind forms the sand around them and the sand dunes. And if you look at this one, it's like a ship going through the water. And this was like one of the first places that I went and visited in the high resolution, and seeing this actually in our dome was one of the things that made me want to come and work on this software.
So how do the pictures I get, right? Take a camera, light, whatever. How are you getting the elevation information?
Yeah, so that's a great question. And actually, maybe what I'll do is just talk about we have elevation data from two sources that we're seeing here, or three. The surrounding elevation data in the background, you can see my mouse for this background area, that comes from the Mars Orbiter Laser Altimeter. And this is like a laser that they shoot down, and then based on how quickly it comes back, they can determine like how high the surface is there, because they know how fast the laser moves.
Not a destructive laser in this case.
Correct. Yeah. But then inside of this square, we're seeing higher resolution height data that is created by using stereo images, right? So they take two images from space, and since they know where the images were taken from, what I mean there is like the angle at which the orbiter was around the globe, and they know it for both of them, so they can determine that like if this line was at this angle in this picture, and this line was at this angle in this picture, high. And this is a process that is actually software that's free open source developed by NASA called the AIM Stereo Pipeline. And we actually have people at the museum downloading these images and working on them and creating these height maps. And one of the reasons I'll show what I think is worth showing here is if I turn off this higher resolution height data, then what you see is a much different look, so to speak. And so it's that height information. I mean, look at this one right here. It's really important to the visualization. It really makes a difference. I'm going to turn it back on just because it's so terrible to see it without it. But I thought it's worth saying. And, that same, we call it a DEM, a digital elevation model, is also really important, I believe, for the landing. And maybe Dan can talk about that. I believe they have those on board, and it uses the elevation models in comparison to the imagery to maybe adjust or know where it's going to land.
Dan, are you able to? Sorry, Brian, you go.
We got two really good questions in the two questions while we're here. What were these called again, Micah?
Well, the light tone mounds in Ganges Chasm. And to give you a sense of scale, we call this one the Martian half dome. This little part right here. Or this part right here.
Like the thing in Yosemite, yeah.
Like
Half Dome being the rock formation in Yosemite.
Yeah, and so it's about the same size as the Half Dome in Yosemite.
Cool. Nice. And the other question while we're here, and nicely you're kind of in the shadows at the moment a little bit, is are those shadows, hey, there we go, rendered, or was the sun, was that just an artifact of the image itself?
Great question. That's actually an artifact in the image. In open space, we are not rendering the shadows based on the sun position, although the sun position is based on the time. So the time in open space and the position of the sun is correct, but the shadows are actually baked into the image. And sometimes you might see that the shadows can actually create an artifact sometimes in that height map that we were mentioning, because it can affect the lines and the determination of the angles.
Micah, just so you're aware, you've been called out for not having a driver's license.
Yeah,
true New Yorker.
Out you don't need a driver's license to fly around Mars.
And then another question.
That was because someone was offering a job, I believe, as the first Uber driver on Mars, since you know the geography
Now
so
we're talking.
well.
Yeah,
Nowhere to go.
right.
But Michael,
how to get us there.
There's another question. I don't know if we'll be able to pull it up immediately, but the color choice on these maps. We commonly see Mars as red and brown, or why are this? What's the color choice here?
So great question, because actually the imagery that you're seeing is black and white. The high-rise camera is in black and white, and so is the context camera. And my understanding for that is that we can get better resolution in black and white than we can in color. And so what we're doing is you're actually seeing this black and white image colorized in two ways. One is that we have a simulated Martian atmosphere. And so based on the sun's position and our input of the chemical composition of the Martian atmosphere, we have this physics-based code that determines what color light to scatter on top of the map. And so you're seeing that. In conjunction with that, you actually see that we take the larger global map that we have in color and we blend its colors into the smaller map. So if I were to, if we wanted to look at this larger color map, that one we have in color. And so we're able to use those colors and bring them into this smaller black and white image. And if I just, maybe I can show us the image in black and white. But it's it was something that I didn't even realize when I first worked here. I was like, oh, these are all black and white.
Because it's
so
the reason
you can
for that
decolorize
is
them.
It's just a single camera, or it's a single filter, basically. So the way you make color images from astronomy, from astronomical images, is you need multiple filters, just like your eyes. The cones in your eyes, you're basically combining three colors. So if you just want to do it the cheapest way, you just put a single camera up there with a single filter, and that's it. And these are not Instagram filters, just to throw that out there.
Well, it's a similar idea. The Instagram filters are showing different colors on top of the picture.
No, they're adding like dog ears and crap like that.
Sorry.
Those are colors. Those are colors.
Micah, this is super cool. I want to keep doing this all night, but I have to keep us on track so we can keep people at home. What do you want to show us another cool thing, and then your other? I know you did another thing.
Oh yeah, let's. I guess quickly. Let me.
We have like 5 minutes. 5 more minutes.
So
we have a request also for Olympus Mons if we have time as well.
Quickly, I'm just jumping to where we're landing, so we could at least take a look at where it is that we're.
Who's we?
Who's we?
Am
I landing?
The four of us. The four of us.
So we being NASA, people, humanity.
Okay.
You know, whatever it is that you want to call it.
Didn't know we had a label for that, but that's fine. That's cool.
Yeah, you know.
I'm in it. Great.
This is
my name is on it.
And it's loading now, but this is the Jezero crater. And so here, basically, you can see that higher resolution imagery that I was talking about, and you notice it's not in the same shape as the strip, and that's because since this is a target landing site, they've taken a lot of these pictures.
So it's a bunch of overlapping.
They know where like every single little boulder that you don't want to hit, you know exactly where they all are.
Is this the 25 centimeter resolution again, or more?
Yeah, but it's loading in. It's that same resolution. Yeah. And actually,
terabytes of data, people, terabytes.
Yeah, and this is where they plan to land, and of course, you know, maybe that's going to change. I don't know. We'll hear about that. But you know, it's they have to plan to land somewhere, and so this is where they plan to land, which is on this awesome delta, which you know you can see kind of looks like a delta you might see here on Earth,
like a river delta.
Yeah.
The fun thing is you're great at flying around Mars, but we don't really know much about the geology on Mars. Is this delta thought to have been caused by water movement in the past?
Yeah, you can see this outflow channel here. If my other map would load, that flows through. And so, and if you look at the elevation map as well, it's believed that this was a basin.
I see.
It has an outflow too on the other side.
Here you can see the like the channel coming through, and let me just.
So if I remember right, they're landing on the delta side, but there's an outflow channel. So this was like a real lake with streams or rivers on either side, like.
Yeah, it's kind of on the basically on the edge of part of the Northern Ocean. So you're pouring out into like Elysium Planitia, a little further to the east there.
And Dan, if we're wrong about this, please correct us.
So one thing I wanted to go here was, on that, I wanted to visit my favorite place here that I call the salamander. The scientists call it Chrism Target 3E12.
Salamander's better.
Yeah, basically this is one of the other instruments that they have to augment the cameras is a spectrometer. It's the CRISM, the Compact Reduced Imaging Spectrometer for Mars or something like that. And they use it to combine with the imagery so you can see the basic, the relative abundance of the minerals in the geology. And so if I just turn it off, here you can see that some of these areas, you can see like maybe a formation right here. And then when you turn on the CRISM, you can actually see that it's different minerals here. And if I turn on the high rise there, you can see a little more detail.
Oh my gosh, you see all the dudes. Mike, is this something that you loaded in, or does this come with like the regular upload?
This is one of the extra things that I loaded in, but it's a free, I got it from the Mars Orbital Data Explorer, and you could download it and add it to OpenSpace yourself. It's not any secret data that I have or anything. But you can see that like
government NASA data.
Using the height map here, you can also see that the elevated areas are green and the lower areas are red. And so they really try to combine all the pieces of data together to do the science, so to speak. There's not only science in capturing all the images and data, but then the science in combining them.
We got to get to the break soon, but I think you have one more thing you wanted to show, right?
I have one more thing, yep. And
I wanted to plug while you're heading. Oh, whoops, we lost.
No, he has to switch over. This
right. Yes. I'll plug then while you're switching because we had to waste some time, right?
Spend time frugally.
Yes.
by talking about how we'll spend the time. Brian,
once the planetarium reopens,
it's open, it's ready.
Okay, but once the planetarium reopens, the Hayden Planetarium, this looks, it looks great on your computer screen, but oh my God, does it look amazing in the planetarium?
Oh my God!
So come and check us out. What is this,
Michael? What are we looking at here?
Okay, so now we're seeing some in progress, not finished work here. But I thought since we're talking about rover and up close that we should get up close as we can. So this is the Mars Science Laboratory Curiosity rover. And basically what we've done is we've taken the images. It has like stereo imaging, and we took the two images and created a 3D model of the surface based on its images, and then put the model on the surface of Mars. So it's basically as close as you can really get to Mars and explore. These rocks are super small.
This is not 25 centimeter. This is like.
Is that like at day? Yeah.
Yeah, this is in the beginning when it's all flat and it's landed in a really flat place. But I'm just gonna jump us ahead, and it's gonna kind of like spit us out somewhere. And apologies while it's loading. That's why it's still.
So can you move through? Here, if you move through time, does it take it to all the locations that the rover went?
Yeah, exactly. And so you see, we're right now in the corner. You can see we're at July 1st, 2015 at 10:37 GMT. And
like
you have to do a conversion.
We've entered into the Martian surface.
Yeah. So part of this work in progress is that it's actually it's loading 250 gigabyte files off of my cheap hard drive right now. I'm not on my work computer. I'm on my personal computer. So it takes a second sometimes to get that 50 gigabyte file loaded. But you see, when they get to a place, they stop and they like take all these pictures, and one looking down, one looking around. So here I'll lock it in place so we can just come up close and look at this one. But they take these like panoramas. And actually, we have all the telemetry data. So you mentioned the laser. Here we can watch as it like uses its hand lens imager, and it like it's gonna like. Well, I don't have an animation of it shooting the laser, but this is where it goes in. It takes a picture and it shoots a laser and blasts up the rock and analyzes the I think that's the cam to analyze the data in the rock.
Awesome.
Yeah, that cam on its face was badass.
So what's the resolution we're looking at now? We said 25 centimeters before. We said 6 meters for the medium.
Yeah,
res.
so I don't actually know that this is like millimeter.
Yeah, I was going to say millimeter. Yeah.
I don't know the data, and you'll notice that since the pictures are taken by the head of the rover, it kind of looks the best when I look at it from his view.
Oh, we're gendering the rover.
Its view.
Oh, its view. Sorry, I just do that to myself. But then if I kind of look this way, it starts looking a little different because it gets the you know.
Oh shit!
Oh yeah, he's moving.
It's alive.
It's moving. It's alive.
Wait, the reason it moved is because you've got the data from the telemetry of when that arm moved.
Yeah, and you can see we're actually going at 30 times speed, so that was 30 times the speed of which it moved. But it did that move on July 1st at 11:17 GMT. Maybe if we jump ahead, we can like watch it drive around a little bit, because it actually sometimes it drives backwards because they drive somewhere and they're not going to waste time turning around. They'll just drive backwards.
So I have a question. So you mentioned like the time for.
Sorry. Okay, Irene, go ahead.
The time for like that's GMT, so like Greenwich Mean Time here on Earth. But like on Mars, they go by sols, which are like off by 40 minutes. Is there going to be like a program where you can like run it on Martian time instead of like Earth time and like kind of like bridge that?
So right now you have to use like a Sol converter like web page or whatever. But I actually was just thinking about that we ought to have that built in. Like, and then I thought, well, why just Mars? I should have that built in for all the planets.
Should. Thanks,
right?
Micah.
Micah's
in all your spare time.
It's Micah figuring out how to keep a job for the next.
That'll keep you busy.
No, I just kind of signed up for 5 years, so gosh.
Woo.
What features do you want to see in open space?
Yes. Wait, hold on. While Brian is asking that question, everybody please ask any questions you have in the chat right now, because we've only got a couple more minutes before we go to the break. So there's, Brian, your question.
There's one great question, which is, can you hack the fucking Mars rovers? I don't know that we know the answer to that. But.
I can't believe I never thought about that. I try not to think about hacking stuff. I'll just say no. Chances are you don't have a big enough satellite dish.
That's what I was going to say.
If you did have a big enough satellite dish, I'll still just say no to not encourage anyone.
If you just hack the Deep Space Network and then...
Well, but it's 3 locations, the Deep Space Network, and it's a series of 41 stations, 41 satellite dishes.
Guys, we don't want to get shut down by NASA. Come on.
Okay. Yeah, let's not. Okay, just kidding. No hacking.
I'm sure it's secure anyway.
Can't do.
I have a story about that if we have time during the break. It's not very interesting.
But,
we have a software question, though.
The relevant item there is that they have to send these instructions, right? Sometimes up to 12 minutes in advance, or 12 minutes before it's even going to get to the rover. So all this driving is planned days in advance. And it's not like if something was going to happen, they could just say stop, because they wouldn't stop for 12 minutes.
For 12 minutes. So we did have a question in here with software. What is a challenge you've run into while developing this software?
Chris, you're killing it today. Great question.
Amazing. Yeah. So, one of the big challenges is resources. I've previously come from a commercial world and I had more developers working on a website to sell iPhone cases than I do on this software to visualize the entire universe. So sometimes that can be a challenge. Another I guess challenge was the kind of learning about the NASA's data, right? We were trying to visualize NASA's data, but that's not one thing. NASA doesn't have one kind of data, right? They have an absorbent amount of types of data, And so it all comes from different places and from different people and in different formats. And some of it's standardized in the planetary data system, and some of it's not. And so that has been a big challenge too.
Cool.
Yeah.
We had a question about the mountains we were looking at and the formation. Anyone know anything about how those formed?
So again, those were the 3 peaks in the Ganges chasm you were talking about, Micah. Do you know formation?
No,
I just assumed they were giant mammoth teeth. There's a thing just like that at AMNH in the Hall of Ocean Life. There's this mammoth tooth. It's like buried in sediment or something, and I'm like, it looks just like that. Like,
and when we get to this level of speculation, you know it's time to take a break. So let's all thank Micah so much for this amazing tour.
Thank you, Micah.
Thank you, Micah.
Micah, if you're sticking around and you want to help judge the acronyms at the end, you're welcome to. Otherwise, thank you so much for joining us. Yeah,
that was super, super cool. Please, everybody, spam thank yous in the chat for Micah. We're going to take a 10-minute break, and then we're going to come back for our final talk of the night. We've got Dan Cotta from JPL, who is talking to us about, I've had a few beers, talking to us about Perseverance landing on the surface of Mars. I've had beers. I'm also feeling the energy of Mars so much. Irene,
you're muted. Yep.
I was saying how Mars was just going to land on Mark's head. Mars.
Who knows what will happen after the break?
Can we bring Micah back onto the stage for a second?
Mm-hmm.
Micah, come back.
Micah, come on back.
Apparently, he had a very important announcement that he forgot.
I forgot to share my beer.
Oh yeah, what are you drinking?
Super important.
It's a Who Farted. Would you like to hold my clipboard? I don't know if you guys are familiar with the Who Farted Brewing Company.
Who farted?
Yeah. Wait, what did you think I said? Yeah, I don't know.
That's what I heard. That's what I heard the first time.
I didn't hear anything.
Exactly. Pale ale. Got it.
I thought that was worth sharing.
Thank you very much.
Thank you, Micah.
It's the perfect segue. Get another drink. We'll be back in 10 minutes, 5 minutes, 8 minutes?
10 minutes.
10 minutes.
Soon?
We're going to put the game back on. Fill this out. The link's pinned in the chat.
Go drink.
Go drink.
Tip your bartender. I might stay on. Am I staying on? Hey, looks like I'm back. Woo. Irene put me on a moment before I was ready. Sorry.
Nobody expects the astronomy live stream.
I literally just scarfed a handful of pretzel nuggets.
And now you're inhaling pretzel dust. That sounds fine.
Yeah.
Nothing like a little AOT to make you choke on some pretzels.
Yeah. Well, so whoa.
Sorry. I'm sorry. I didn't mean to.
I'm gonna mute myself. So I'm.
Okay. So I hope that game's going really well for everyone. Brian just wanted to come in and make some announcements, I think, and I just made him choke on pretzels. Sorry, dude.
No, it's fine. Worse things have happened, certainly. Yeah, no, we're so glad to be back on with all of you. Thank you, everyone, for joining us. Earlier in the chat, somewhere, I'm scrolling up through the chat, Kelly posted a link. Oh my, we've had a lot of chat.
Chatty bunch.
Kelly posted a link, but had to go, so I'm going to repost it in a second. That is not the one I'm trying to repost.
I'll find it. You talk.
All right. So, yeah, we have friends. Those of you that have been doing this for a long time know Emily Rice and may know Kelly also. They now are running Startorialist, not just a website anymore for astronomy fashion, but they are selling. Oh, look at that! They are selling some really cool stuff, and they're doing a whole bunch of Mars stuff right now.
And I actually got this Mars mask like a while ago. It's my keep safe and stay on Earth and be Marsy.
Cool.
Mars 2020.
That is the official Mars 2020 logo too, I believe.
And they come in silver and white also. That's just one of the amazing, fun, and practical things you can find on Startorialist. That's all I had to say about that.
But yeah, they're really putting some fantastic stuff on there. I am just about ready to buy one of the T-shirts with the Perseverance print on it. What else has been going on? We had a bunch of thank yous from Micah. Ooh, Irene, you got some love for the Aurora behind you.
I did. Yeah. And there's another one behind that. It's another one from the same student. They did the eclipse one year and they went Aurora hunting and then they send me awesome pictures of the stuff that I missed.
Oh.
Very sweet.
And whoa, still coughing a little bit. And yeah, the game is running. So do get your answers in for that. I think I pinned the comment. It's so far up at this point. I can't even find it yet again. So anyway, submit the game. I'll put the link in the chat in a second in case the pin has stopped working. And we've got some fantastic, NASA stickers and little NASA flyer to send to the winner, and I think the acronym
NASA
winner.
flyers. Are we sending them Ingenuity?
No, the shuttle flyers.
Oh, the flat ones. The air. Yeah, got it. Okay, I was like,
so
wow,
you put it together and you can chuck it off into the future. And yeah, okay, thank you. I was going to ask you to move that because it's covering one of those images.
All right, I'm just gonna go eat my pizza. Leave me to
it. And yeah, so I think I have some good stuff to send to the acronym winner as well. And you know what? I haven't looked to see if we have some submissions for the acronym. None yet. Oh, yep, nope. I just had to reload. Ooh, we have some good.
We have
one
some
that
questions.
was already in the chat.
Yeah.
Ooh, we have one named after something I definitely love. I'm not going to send them out yet.
Can we put up a quick question, Brian?
Yeah, what do we got?
I think this is a good pressing question. I get this a lot.
Yes. Chris, good friend of Astronomy on Tap. We don't know yet. I will have to get back to you.
So we're aware, we're thinking on it, we're working on it in all our spare time, which is not a lot, but but it's in there somewhere.
Too, considering there's no more commute and I'm only working 3 days a week right now, how do I not have time?
You're living on Mars
I do want to plug though. We have a couple of slides in this little thing. Irene does run some. You run some weekly live astronomy things with some of that software you were using earlier. No, you don't use the EYES software.
So every now and then I've used NASA EYES a couple times. I've used it in class and I've used it once or twice in the live streams. I mostly use Stellarium and open space. So we do like what's up in the night sky in Stellarium, and then we fly around the universe in open space. It's like a very casual, some more cash than others. The other, like last week, I was just like, I just feel like chillaxing around Mars. So I kind of just like rode around Mars for a little bit. It was awesome. Yeah.
Cool.
Very relaxing.
And that's free on your Facebook page?
I charge $15. No, yeah, it's free. It's free, and it streams on the Friendly Neighborhood Astronomer Facebook. Maybe I'll do it on the YouTube as well. It's kind of why I wanted to use the StreamYard for that, but we'll see if that works. But yeah, I'll put that link in there for the Friendly Neighborhood Astronomer.
Cool. I've also been, if you have a middle schooler or someone around that age, with the Brooklyn Public Library, I've been running a little series called Give Me the Moon Over Brooklyn, which is an old song from the 1940s, very aptly named for an astronomy series from the Brooklyn Public Library. It's once a month on, it's usually the second or third Monday of the month, I believe, after school, kind of meant for middle school age. And you know what? Yeah, they are. Part of the inspiration for the acronym game tonight. Can you full screen me for a moment?
Oh.
Was the last one, and we were talking about entry, descent, and landing. Nope, that's not me. There we go. And I made these little drawings of the egg carton, the carrier and robot to another planet, and I'm very proud of these. I'm sorry. The egg shell, the spacecraft holder of equipment for landing and deployment, which is hopefully a really nice segue into our next segment. Yeah, we can bring me back. There we go. Me back from the brink there. Oh, it looks like it's just me now. So yeah,
I'll keep you company. I got your back. Hi.
Get your answers in for the chat. Get your final acronyms in, because I will be starting to judge those as the next speaker is talking.
And we also have some suggestions for possible, venues. We have Barclay Center.
Oh, sweet.
Littlefield. Littlefield might be more up our alley. I think individually, some of us have done other events at Littlefield in some way, shape, or form.
Yeah, we did Astronomy on Tap there.
Awesome. I've done observing and stuff there, and some live online things as well. Secret Science is there, I think. They do like the quiz nights and stuff. If you like that kind of, I just missed the astronomy one. I had just reached out to the Secret Science guy, and he had just done an astronomy one. I was like, I can't believe I missed it. But yeah, they have good fun things.
We had a little suggestion too to keep some of the online versions, and these are fun. I think we could definitely do that. So
that's something that we've done with the Amateur Astronomers Association too. With our classes, like we've moved everything online, but even when we go back to in person, we'll probably still have online classes and some of the public lectures online as well, because you have a greater reach. Like there's more people that can make it when it's online sometimes, and people who wouldn't be able to make it in person. So yeah.
So I'm going to open my second drink for the night here. This is an other half Imperial Stout with vanilla, figs, almonds, and cinnamon. But it's called, it's hard to even read it. Deep Orbit, something like that. And look at that label. Ooh, nebular label.
Wait,
hard to see.
Where's Mark?
Where is Mark?
We lost.
Mark went to get a drink, I thought.
Where? What is that? It's
It's actually Mars.
Mars. I'm here. I have heard you speaking of me.
I don't know what you're talking about.
No Mars.
No, we're talking about Jupiter today.
I have taken the form of this mortal to hear about the things you have planned.
Things
We have beer planned. Have a drink, Mars.
I will.
What does Mars drink?
Yeah, what does Mars drink?
Pilsner that Mark was drinking earlier?
Mars drinks only the manna from gods. But
oh my god!
This mortal vessel drinks sweet action. 6 points.
Nice. Look at how fucking dark this is. Ooh,
it is dark, Brian.
Dark as Mars on a winter night?
No, we do have winter. We have seasons and axial tilt.
Oh yeah, happy equinox, Mars. Congrats.
Thank you.
I thought it was the vernal equinox.
Thank you for remembering. Not many do.
I got your back.
Very kind of you. Yes. You know, Mars as a god, as you humans used to call it, you know, had many names. There was the fire star in Japanese and Chinese mythology and astronomy. There was Nergal in Babylonian. There was a Hindu god as well named after Mars. But nowadays, I have to take a different form. I'm not just the god of war anymore. You have so many more things, you humans. I'm also the god of X Games and stocks.
Stocks?
Wall Street bets.
Wow.
Me.
On Mars.
That's like a war, I suppose.
Really?
Yes.
Wow.
So you're responsible for GameStop's recent
that was me.
That was Mars.
My
you're so high in our sky right now. It's like, I don't know why more people aren't out just like Marsing it up.
I know.
I guess that explains a lot why you're all.
I'm also upset about it. These laurels did not work as well as I wanted them to.
Well, it's not like you're gonna sit on them. You wear them, right?
Never.
You sit on your laurels? I thought you do sit on your laurels.
Mars doesn't sit on their laurels.
Yeah. Okay.
Mm-mm.
I used to receive such gifts as Mars. You know, sacrifices, and now you just keep sending me rovers. I get it. I've got enough of them.
There's only like 2 working.
There's only 2 right now, but yeah, I mean, everyone needs a robot collection, Mars. Indeed. They're all the rage here.
I'm god of robots. Anyway, I hear I'm receiving a new rover soon. Is this true?
Helicopter? Would you like a plane? We could send you a plane, something that flies in the atmosphere.
That's a lot.
It's a lot. Don't want to like stir you up, mess your hair.
I wish to learn more about this rover that is landing tomorrow.
Do we have something we could talk about that, Brian? I'm getting a little nervous. I'm getting a little anxious. Yeah.
Am I supposed to introduce him?
Formally, I'll introduce them. Yes.
Mars,
let's bring on our next speaker.
It is a good thing for me to say. I hear your truth teller, or scientist, or engineer, as you call them these days. We have a great truth teller called Dan, who is a mechanical engineer at NASA Jet Propulsion Laboratory. In non-pandemic times, he likes to travel and play soccer, but in pandemic times, he likes to watch Netflix and try to keep his young kids from destroying his house. And now he will tell me about the next rover coming. Let's welcome Dan, everybody.
Welcome, Dan.
Thanks, Dan.
Wow. Thank you, Mars. I don't think I've ever been introduced by Mars before. That's amazing.
Have a deity sing your praises and read your bio.
I've just got Maven and MRO all around me.
Downhill from there.
By the way, we have tons of comments in the chat about Mars and questions, mostly questions for Mars's sanity here, but I'm going to just let Dan go and
tell me which god, what other things I should be the god of. Keep them busy while Dan tells us amazing things. Dan, please.
All right. I don't know if I can top any of what just happened. That was too good of a setup. But thanks. Thanks for the intro. It's super fun to be here, by the way. I've never been at Astronomy on Tap. This is my first time, and I'm having a blast. So thanks for having me.
Thank you, Dan.
like Mars said, I'm an engineer at JPL, and everybody at JPL is super excited about the fact that we have a freaking robot landing on Mars tomorrow. And this is something that we've been working on for the past 8 years. And so people have been, living and breathing this thing for the past 8 years. And, usually we're talking about it like, oh, it's coming in a few years, or, oh, it's coming next year or whatever. And so the fact that I can say, no, it's not coming in 2021, it's literally landing on Mars tomorrow is incredible. It's incredibly exciting.
That's got to be a great feeling.
It is. So I'll talk, like a little bit about like what the mission is going to do, and then how it's going to land. The big question that we're trying to answer with Perseverance is, did Mars ever have life? We have established with previous missions that Mars had water at one time, liquid, lakes and rivers on the surface billions of years ago. And we've established that it was a pretty hospitable place for life with the Curiosity rover. And so the next question in the series that we want to ask is, hey, was there actually life ever there? Or actually, is there life still on Mars? And we're not talking about like little green men life. We're talking about like little microscopic microbes and bacteria type of life, which could possibly still exist on Mars, or maybe, was there at some time in the past. So that's the key question that we're trying to answer. So this rover, Perseverance, is equipped to answer that question. And it's going to be looking at a lot of different things. It's going to be looking at the overall geology of Jezero Crater, where it's landing. It's going to be looking at astrobiology. It's going to be looking super up close at rocks and soil samples to try to figure out if there are the chemical traces that are consistent with current or past life. It's going to cache samples, which is my favorite part of the mission, and I'll talk a little bit more about that. And it's going to prepare for humans. You guys were talking a little bit earlier about MOXIE, and so that's a test to see whether we can convert Mars's atmosphere into oxygen for future human landings. And so it's paving the way for future human exploration as well. So lots and lots of things that are kind of packaged into this one amazing, small SUV-sized robot that's landing tomorrow.
This is like everything on it is about life, essentially, if I remember right, basically, right?
I don't know that everything about it is about life. I mean, there are there are
cameras
other,
they're telling you where to go and whatnot, but
yeah, there's other instruments, that are looking at other things. But I think sort of the main like scientific thrust of the thing is life. That's sort of the main idea.
This pleases me.
Excellent. I'm glad. We probably should have checked with you a long time ago about that, Mars, but I'm glad since it's happening tomorrow that you're good with it. So there's a whole bunch of science instruments that are on board this rover. I'm not going to go through all of them, but one thing I wanted to point out is it's got this amazing robotic arm on the front of it, and there's basically a scientific toolkit at the end of that robotic arm that's going to be able to get up close and personal with all sorts of different interesting rocks. And like you guys talked about earlier, it also has a coring drill bit at the end of that robotic arm. And that drill is going to be able to drill into rocks that are particularly juicy and interesting for us, take core samples, and bring them back to its caching system, which you can see sort of in the front of the body of the rover. And what that caching system has on board is a little bit over 40 sample tubes. Those are basically kind of pencil-sized, super clean tubes. And it can load samples into those tubes, put a cap on the top, and leave those tubes on the surface of Mars.
So it's going to clear its cache?
Yeah. Sorry. And we're working on the next mission already, which is going to pick up those tubes, load them into a rocket, blast off from Mars, and return them back to Earth so we can study these amazing, pristine Mars samples in laboratories here on Earth.
This is a sample return mission as well?
This is, you can consider it like the first leg of what we call Mars sample return. So the first leg is to go get the samples. That's what Perseverance is doing. And we're starting to work at JPL on the next leg, which is grab those samples and bring them back again.
This is very, very amazing. But the drilling, it will be gentle, yes?
I don't know if drilling can be gentle necessarily. There will be holes. So yeah, it'll
There's
leave a mark.
Novocaine involved, though, I think.
This does not please me, but please continue.
Yeah. You can just drink some beer and you won't feel a thing.
Good. I will.
So yeah, this rover is sort of loaded up with this suite of science instruments that are going to explore Mars in its own right, and then pave the way, to do this first leg of this Mars sample return, which we're super excited about. It's also going to get amazing footage. It is loaded up with cameras every which way. It's got cameras that are going to get microscopically close to the surface of Mars, and then it's got the kind of wide sweeping views as well to get amazing views from its mass. So it is, we're going to get some amazing footage from this rover.
But I don't see a selfie camera listed there.
There will, I think inevitably there will be selfies. I don't know which camera is going to be taking the selfies, but something's going to take the selfies. Plus, it's got a drone. I think that's my next slide, to take selfies of it. And there it is. Everybody needs a drone now. And so it's got a drone on its belly. This is a technician in the clean room at JPL in a bunny suit to keep everything clean, installing the helicopter on the belly of the rover's flipped over in this view, and so the helicopter is getting installed on the belly. The rover's going to land. The helicopter is going to drop off onto the ground off the belly. The rover's going to drive away to a safe distance. And the helicopter will take off. And it's kind of going to be like a scout for the rover, and scout out, driving locations for the rover to head. Super cool. First time we've ever done anything like that.
A question. My atmosphere is very different from Earth's.
Yeah.
You know how this drone reacts to it?
Yeah, so we actually had to do a lot of crazy tests of this drone to prove that it was going to work in Mars's atmosphere. They had to fly it in essentially a vacuum chamber at JPL. So they took this chamber and they sucked almost all of the air out of it to get it down to 1% of Earth's atmospheric density or so, which is what you are, Mars. And then they're able to show that this thing is able to fly and maintain control and stability under those crazy conditions. But its blades go super, super fast, and it does not weigh much because to fly on Mars, it is a challenge given the atmosphere, and you can't lift a lot of weight.
This pleases me. I'm glad you have thought of this.
We had a good question in the chat too about what's the difference between an engineering camera and a science camera.
Yeah, good question. So engineering cameras are more for like navigation for the rover. Like, hey, where am I headed? Are there hazards in front of me? They're not really intended for scientific analysis or anything like that. They're just to make sure the rover can do its thing. And then the science cameras are for that exact purpose, right? They are precisely tuned for whatever science instrument and measurement we want to take.
This pleases me.
Thanks, Mars. We talked a little bit already about the landing site, Jezero Crater. So this is a site that was specifically chosen because it's a place where life really may have once existed on Mars. I think somebody showed this exact picture before, but you can really see evidence of a river flowing into and creating a delta in this place where there was an ancient lake. And anywhere on Earth where you have a situation like this, it's just teeming with life. And so this, to us, to scientists, is the perfect place to go and look to see if there is life or if there ever was life on Mars.
I'll never tell.
So Perseverance launched a beautiful launch from Cape Canaveral on July 30th last year. It's been on its way to Mars for the last 6 months. And as we all know, it's landing tomorrow. And landing on Mars is hard. And we talked about this. The atmosphere is really thin. If you're a skydiver on Earth and you're in the kind of classic like selfie, like belly down pose, you're going about 100 miles an hour or so. And at Mars, doing the same thing, you're going about 500 miles an hour. It's hard to get the atmosphere to slow you down very well on Mars. And that's true of our spacecraft too. And so that's kind of the trick to landing on Mars, is how do you slow down in time before you crash on the surface? So I'm going to pop out of this and show an animation which kind of walks through what's going to happen during the landing of Perseverance tomorrow.
This is a terrifying. Is this the one with the scary music?
I muted it.
Okay. Okay. The scary music is just too much.
Okay, Irene, it's okay.
It will not scare me.
It starts with this cool kind of like sweeping like Star Wars, like they wanted to add some drama to it. So sweeping across the stars, and then the spacecraft is heading right at you. So this is kind of showing like the last moments before the spacecraft is about to enter Mars's atmosphere. And I'll pause it here. So the first thing that's going to happen, and this is about 10 minutes out before the spacecraft enters Mars's atmosphere and starts the 7 minutes of terror, is we separate off the cruise stage. So this kind of donut looking thing is called the cruise stage. That's actually what sort of steered us all the way to Mars. We don't need it anymore. So we separate it out and it burns up in Mars's atmosphere. We're done with it. So thank you, cruise stage. We're done with you. In a way, Mars, you can think of, there are a lot of sacrifices that are made to Mars on the way to landing the rover, because there's a lot of wreckage and things that we burn up in the atmosphere just to safely land the rover on Mars. So there's sacrifices along the way.
Does the cruise stage also land on Mars?
No, it burns up. It does not make it.
Good.
There's other stuff that's going to crash into Mars, though. I'm sorry. We'll talk about that. So about 10 minutes after we separate off the cruise stage, the entry capsule starts to enter Mars's atmosphere. It's going to streak into Mars's atmosphere at about 13,000 miles per hour. And so the trick is, you enter Mars' atmosphere at 13,000 miles an hour, you've got 7 minutes to slow down to 0, basically a soft landing. And so, how do you do that? And so all the tricks of entry, descent, and landing are just ways to slow down and get more and more velocity out of your spacecraft. So the first thing that's going to happen is this entry capsule enters the atmosphere and it heats up and starts to glow like a meteor as it streaks across the atmosphere. And it slows down significantly. It slows down from about 13,000 miles an hour to about a little under 1,000 miles an hour. So most of the speed actually is just burned off from drag on this entry capsule as it's screaming through Mars's atmosphere and heating up. This capsule has to be covered with this special thermally protective material because it gets so hot. If the rover was exposed to these temperatures, it would just melt. And so this material is designed to actually sort of melt away. It's called ablate away. And so the material loses mass and goes through a phase transition to protect the rest of the spacecraft as it's entering Mars's atmosphere.
Does your entry, is it very shallow to get as much atmosphere as possible?
Yeah, it's a pretty shallow entry angle. Yeah, exactly for that reason. And you don't want to go into too steep, or you'll just heat up and burn up basically. And so you need to go in shallow. It slows you down and it prevents you from heating up too rapidly.
Yeah, so I think we have a question kind of about that. Is this glowing? is that basically energy transfer that's happening as it is like kind of glowing in there?
Yeah, so there's some energy that's being lost just due to the fact that it's glowing, and so you've got phase transitions and the fact that you know, that it's glowing as well, that's getting rid of energy from the system. So all of that is acting towards slowing the capsule down as it's descending through the atmosphere.
And when you say phase transition, you mean it's just melting away, basically?
It goes from a solid to a gas. Yeah.
Okay.
Sublimation.
Yeah, it doesn't mess around with being a liquid. Yeah. So yeah, this the material on the front of the heat shield, that's the front of this. It's kind of like a heavy cork. It's called pica, and you basically just have to size it so that it's thick enough that you don't burn all the way through it. Because if you burn all the way through it, then you're going to melt the spacecraft. So there's got to be enough that you don't burn all the way through.
Don't melt the robots. Mars needs more robots for its collection.
I would like another robot, please.
So we keep screaming through the atmosphere here, slowing down. Once we get to a little bit under 1,000 miles an hour, about Mach 2, it's time to open up the parachute and slow down some more. And so this thing gets ready, opens up this big supersonic parachute. You know, this is like the size of a house, and it snaps open in about half a second. It's a big parachute. And this slows us down from about 1,000 miles an hour to about 200 miles an hour. You know, on Earth, a parachute this big would slow you down a lot more than that, but we're still going 200 miles an hour, even at the terminal velocity of this parachute. So there's more needed even after you open up this chute.
You called it a supersonic parachute. What does that mean?
It just means that it is designed to open up under supersonic conditions. So we open it up at about Mach 2.
Supersonic as in Martian atmosphere or Earth atmosphere?
Martian atmosphere.
So Mach is always relative to your surroundings, right? How fast the sound is moving wherever you are.
So it's
location sensitive.
We did, interestingly though, test this parachute in Earth's atmosphere. And so we actually fired something called a sounding rocket that went up into Earth's atmosphere at an elevation where Earth's atmosphere is about the same density as Mars's atmosphere, and opened up the parachute under the same kind of supersonic conditions in Earth's atmosphere as it's going to see at Mars, to make sure that it's going to work in exactly the same kind of environment.
Because I was going to say, is there like a wind tunnel where you could test that thing, or you just have to? Is that the only way you can do it? Are the wind tunnels all too small for this thing?
There's a wind tunnel. There's a huge wind tunnel up in Northern California, and we did test this in that wind tunnel. We actually broke that wind tunnel in the process, but that's another story.
Do tell.
But the problem.
That's a great story.
The problem with the wind tunnel is that because it's at sea level, the air of the wind tunnel is this, you know, thick sea level air. It's not Mars air, and so that means that the dynamics of the parachute opening are totally different than they actually are. Right? Like I said, this parachute opens up in half of a second at Mach 2, but in the wind tunnel it takes like 10 seconds to kind of like slowly unfurl itself and then just decide to open. And that actually makes a big difference for whether the parachute is going to work or not work. Those dynamics during the opening. So we use the wind tunnel to sort of prove that, it's probably going to work. But then we use the sounding rocket to show, really in that same relevant environment, that it's going to be able to do its thing.
This pleases me.
All right, we keep moving down on the parachute. And the next thing that we got to do is we've got to lose the heat shield. So this is another sacrifice to Mars. So that heat shield blasts off from the rest of the spacecraft. And the reason we have to do that is because we need to see Mars. All of the cameras and the radars that are on board are inside of this capsule. And so this is the first time that the spacecraft gets a direct view of the surface of Mars. And we can see how high we are really, because we have an estimate of it before, but now we really know, and how fast we're going. And so now it sort of gets the truth behind that. And the next step after that is we're going to drop out from the parachute and fire rockets. Because again, we're still going 200 miles an hour towards the surface, and we got to slow down more. And so that's where the rockets come in to slow us down. So we sort of steer away. And another thing that's happening during this time is that there's a camera on board the rover that's looking down. And someone mentioned this earlier. It's looking down and taking photographs of the landing site that we're kind of headed towards on Mars. The rover's computers are preloaded with maps of Jezero Crater. And the team has looked really, really carefully at all of that same elevation data to sort of pre-code the map with the locations to land that are safe and the locations to land that are unsafe, because there's a giant boulder or a bit, part of a crater or a cliff or whatever. And so as the rover is coming down, it takes photos and it says, hey, am I coming down in a safe place or am I coming down towards an unsafe place? If it's safe, then that's great, and it just keeps coming down. If it's unsafe, then it makes a beeline and flies over to the nearest safe location, and it lands there. So it's got those smarts built in.
What if the second location isn't safe?
The second location is safe because it's sort of that's part of the algorithm, is it knows all the safe and unsafe locations. So it's like, where is the nearest safe location? Go to that safe location.
So I think we have a couple of questions. One you may have just answered. Chris is asking, are these steps automated? Are the commands being sent from Earth? Sounds like automated.
Yeah. So this is part of why it's called the 7 minutes of terror, because it takes 12 minutes for the signal, the speed of light, to travel from Mars back to Earth or vice versa. It only takes 7 minutes from the time the spacecraft enters the atmosphere until the time that Perseverance touches down on the surface. And what that means is, at the time that we get the signal from the spacecraft that says, hey, I'm entering the atmosphere, that was 12 minutes ago. And that means that it's actually been on the ground already for 5 minutes. So we have no way of joysticking this. There's no way on, that from Earth we can control it. And so all the smarts, all the decisions have to be in the software on the rover, and it's got to be able to do everything on its own. All we can do on Earth is sit back and watch and hope that we did everything right.
Hope there was no error in the 5,000, however many hundreds of thousands of lines of code.
Totally.
There's another kind of related question about the sequence. Faisal says, you notice the animation, the capsule is not directly under the canopy for quite some time. At what altitude does it fly straight down? So I don't know if we've gotten to that part, if it's still adjusting.
Yeah, so I don't know the exact number on that, but it's several kilometers up that it separates out from the parachute and does its divert, and then starts descending straight down towards the surface. So couple kilometers, but I don't have the exact number.
And question for me real quick. Sorry, Mars, I hope I didn't cut you off.
I will ask mine after you.
That's so the image that we're looking at now, that's still Ingenuity, like just riding on the belly still, right? Just
yeah, thanks. I should have pointed that out. So this is a little protective shell. This is like the iPhone case over Ingenuity.
I'll look at my phone like,
I am the god of iPhone cases.
You'll love this then. You're getting a new one. So there's all sorts
the iPhone 21.
There's all sorts of debris and rocks and just gravel and shit that just gets kicked up by these rockets as they're approaching the surface. And the helicopter would just get pelted with them on the belly of the rover. And so this protects it. It's gonna drop off, after it lands, but it's there just to protect the helicopter.
My question is, how many places on my surface were in contention for landing? Why was this one chosen?
Yeah, there were a lot. There were years and years of meetings and debates of all of these planetary scientists kind of duking it out with all of their favorite landing sites and why they thought that it would be the best. And so there were dozens of landing sites that were in contention. I think pretty quickly they narrowed it down to, I think it was the top 4. And at that point, it was a combination of what is the scientific utility, what is the scientific benefit of each site, and also what is the landing safety of each site, because the different sites have different funky things about their topography that are going to make them more or less difficult or risky to land on. And so Jezero was that sweet spot of, hey, we think we can land on this. We think that it's safe enough to land, and it's got amazing scientific benefits, because of the delta that was there.
So Micah threw into the little backstage chat here. I think there was a science meeting at AM&H partially in the planetarium where they were actually looking at these sites using the data that Micah was flying around.
That's amazing. Yeah. It's a small community, right? We're all using the same stuff.
Yeah, that's amazing.
So we're on the rockets now. So the rover is kind of underneath here, and then the thing with the rockets above is called the descent stage. And so that's firing these rockets, steering over to the safe landing site, pinging its radar off the ground to figure out where we are, and getting lower and lower to the surface. And once we get low enough, then it's time to release the rover in the famous sky crane.
Sky crane!
Sky crane!
And so there it is. We lower the rover down on ropes. There's a special mechanism that's up here in the descent stage to make sure that's a gentle process. You don't just want to drop it and have it snap at the end of the ropes and break everything on the rover.
No,
so
we don't.
It's this gentle kind of unraveling of the ropes and kind of control in a controlled way, lowering the rover down until it's about 25 feet or so below the descent stage, and then it comes in for this soft landing directly on its wheels. Once we've landed, rover cuts the ropes, descent stage flies away for an honorable death. Another sacrifice. Yep. And the rover is left on its own, ready to rove.
I welcome this gift.
And it's still waking up on its own. This is not directed by Earth, right?
Yeah, so that's actually part of the landing sequence, right? It lands and then it does all sorts of self-checkouts, hey, am I alive? How am I doing? It takes a couple pictures. It sends them back to Earth. And so there's that initial sequence that it does just to check everything out and make sure that it's healthy right after the landing.
And that's when everyone starts yelling and screaming tomorrow on the NASA feed, I hope.
That's exactly right. Yeah. When as soon as we get that confirmation that it's, wheels down on Mars, stable, that's when people go nuts.
So what time should we be tuning in tomorrow?
Yeah. Good segue. Where are my slides?
So I'm sad while Dan's switching things, I was sad to see the exploration rover method never got repeated with the airbags and the bouncing for half a kilometer.
Grapes. A bunch of grapes was cool.
It was annoying.
Didn't it just tickle just a little bit?
A little massage on the surface.
Dan can say better than me.
That was actually considered. So Curiosity was the first rover that used this sky crane maneuver, and there was a big debate in the early design days of Curiosity of how do you land this thing? What is the right way to do it? And of course, we had just landed things using airbags, and so that was one of the main contenders. But the sky crane won, and a big part of why that is the case is that when you've got airbags, you then have to somehow maneuver your rover over the airbags or past the airbags, and you always have this risk of getting snagged. You've got all this just loose fabric everywhere from the airbags, which are deflated at that time. And so there's a risk of getting snagged, entangled, and the rover just never gets off of the landing pad. And when you land the rover directly on its wheels, you just don't have to worry about that. You're just there, and there's nothing that you have to maneuver your way around. The other, another big consideration here, and a reason why we like the SkyTrain, is that it keeps the rockets up relatively high. Like a lot of other landers that land on legs, the rockets come down with the legs. And so the rockets are just operating like all the way down, and they're just like blowing little craters in the surface of Mars, and disturbing the surface a lot. This way, there's still stuff that gets kicked up, but the rockets are kept, 25 feet above the surface. And so there's a lot less stuff getting kicked up as a result of the landing.
This pleases me.
Anybody can watch with JPL. We're all getting the same information at the same time. You can watch it live tomorrow. The broadcast starts at 2:15 Eastern. The actual landing, like the end of the 7 Minutes of Terror, is around 3:55. So if you tune in then, you'll have missed it. So don't tune in then. But that's when things are happening. There's this long URL, but honestly, you can just like Google like NASA or Mars rover, and it'll be all over the place. So you can find it pretty easily.
I put a different version in the chat. It's the toolkit landing site, whatever, something.
We will spam our social media.
The last thing I wanted to mention is peanuts. So there's a long tradition at JPL. It goes back more than 50 years of eating peanuts for critical mission events, for luck. So everybody at JPL is going to be doing this. People in mission control are going to be doing this. If you have a peanut allergy, please don't do this. But if you're good at eating peanuts, then grab some and munch along during the 7 Minutes of Terror.
It sounds like that would go well with beer too.
Yeah.
And can we just drink during the 7 minutes? That sounds like a good idea. I think that's encouraged, and the peanuts go. Would be a great accompaniment.
What will you be doing, Dan? How will you be?
Good question.
I'm going to be on a Zoom with some of my colleagues, kind of collectively freaking out and watching the same feed that everybody else is, and eating my peanuts and probably drinking something as well.
Good. We need questions in the chat because we have to keep moving. So please.
There was a question from the chat. Who gets to decide the landing procedures for the rovers? I really wanted grapes. Can I, like, if I go work for NASA, can I bring the grapes back? Who do I have to be to make that call?
Yeah, so I think that there's a lot of people who are sort of focused on this phase, this entry, descent, and landing phase. And so there's a lot of people who need to get together and figure out what is the best option for the landing system. And but it's the engineers who work on the team who are going to figure out, based on the needs of that mission and what it has to do, what's the best way to land. And we've gone through a few different landing techniques over time, and this is, for this mission, for this type of rover, this is what we think works best.
And another one regarding the descent. Where does the descent stage fly off to? So it flies off, and also I'm just curious about like where these other things are landing, right? The parachute, there's all this other stuff, that's all these other bits of sacrifice to Mars.
I'm also curious.
How far away are they landing? Where do those go?
I answered that one. It was off to the left somewhere.
Yeah, I saw the off to the left. Which left? My left or Mars's left?
Mars
like
left.
How far?
So there is this kind of like series of like debris that's just on the surface, right, in this zone, and then the rover is there too. Actually, when Curiosity landed, it was really cool because Mars Reconnaissance Orbiter with its high-rise camera took photos. It passed over and took photos of the landing site, and you could see all the stuff that had crashed, and you could see the rover. So you could see the parachute, and you could see the heat shield, and you could see like this kind of scar like that was left on the terrain when the descent stage crashed and like exploded because of all its fuel. So yeah, all this stuff is kind of in the vicinity, probably like hundreds of meters or a few kilometers away. But I hope that we'll get some cool pictures from the orbiter as well, showing where everything ended up afterwards.
Yeah, I've done the searches, like when I'm looking at the landing sites and picking out there's the back shell, because they have maps, and I think Micah was commenting in our chat as well. Like you can see these with the high detail resolution that we get from the orbiters.
Totally, yeah.
And some of these cameras are taking pictures on the way down too. There'll be some interesting stuff going on tomorrow. So definitely tune in starting at 2:15 and get ready for roughly a 4 o'clock or 3:55 launch Eastern time, in case anyone is not in the East Coast of the U.S. But Dan, thank you so much for letting us know a little bit about entry, descent, and landing, and for dealing with all of our drunkenness, and for dealing with Mars here, who is a surprise visitor.
Dan, I did not know you would see a planet that you're landing a rover on, but thank you for coming.
Thank you, guys.
If you can, stick around, help us judge the next, or the answers, not the answers, whatever. The contest thing, the
acronyms.
So,
sure.
Thank you so much, Dan. Let's, Irene's in charge of production here, so look at that. That's the three of us again. So again, thank you.
Do we have a thing to put up?
We do. It's already. I think it's already shared, or did I not? I had to reshare it. Hold on.
I would
not in there.
Thank you for talking about me. I hope we all watch the live stream tomorrow. It will be a great day.
But we'll be a little out of sync, Mars. A little off by about 12 minutes.
I'll know before you do.
That's true.
Mars, you're our future.
So thank you, everyone. It is so much fun to do these. We are Astronomy on Tap, as you probably know. Check out the Astronomy on Tap main page for other performances around the world. Hello, Alex Tichy, too. I don't know if he's actually watching, but he has moved to Taipei, and they have an Astronomy on Tap there as well. Alex Tichy being our usual fourth co-host, who has gone off to postdoc land in Taipei.
Hello, Alex.
So yeah, this was Mars. Hopefully tomorrow there's a soft landing followed by a whole lot of hard liquor, or peanuts, I guess. Also,
peanuts
no,
and
that's
liquor.
during. Yeah,
and peanuts,
peanuts and Mars and booze and robots.
Yep. Sounds like a fun evening to me.
We are past 10 o'clock. We should keep moving.
On the eastern side of things. Yeah. All right. So thank you to Irene, to Micah, and to Dan for presenting tonight. Mark was here earlier. Mars is here now. I am Brian Levine, your co-hosts. Check out Irene's Friendly Neighborhood Astronomer page on Facebook. Check out my Give Me the Moon Over Brooklyn Middle School Science series at the Brooklyn Public Library. But let's get to the game. So Earth or Mars. Oop, my cursor's in the way there. Earth or Mars. So A, B, and C.
I don't know.
Well, there's only one of these from Mars, and I believe it is... Oh, there we go. B. B is from Mars. Meteor crater, lovely looking there, and Earth is Grand Canyon. And for A,
Arizona, and Mars. You're saying Arizona looks like Mars?
Arizona is Mars.
I'll get this one. I know I can do this one. Okay. D, Earth, E, Mars, F, Mars?
I say F, Mars. Yeah. Wait, Mars.
Haven't gotten any better since 2014. Mars.
No. Why Mars?
All right, and the third panel.
I won't try. I don't want to embarrass myself.
I'm gonna guess the top one is Mars, and the others I don't know. Maybe
I is Mars. That's just fucking cool. It's all.
Is that a skylight? It's a skylight.
Basically. Yeah.
But is this over the poles?
I'm not exactly sure. I'm using old images that I did not find myself. So,
if it's carbon monoxide ice, then yes. Or carbon dioxide ice. Anyway, cool.
All right, and we do have a single winner here. Oh, it is with 8 out of 9. Not bad.
Wow.
the
Mars.
contrived organism reacting randomly in excess. It's Corey. Corey has won the Mars, Earth or Mars game. All right,
Corey.
You know me better than I do.
Can we bring Micah and
Dan back in?
And Dan back in if they are here for the acronym game. So Micah and Dan, we have. Oh, right. We were throwing some examples out there earlier, but there is actually a website that collects astronomical acronyms, bad or dumb or overly forced astronomical acronyms, called Doofus on Harvard's website. I mean, this is just a small portion of them. I personally like Fucker, the Far Ultra Chromatic Rocket, and Holy Cow because it uses a subscript in the acronym.
That seems like cheating.
It does. So I'll post that at some point, but there is just an amazing list of hundreds of just bad acronyms. But these are not what I was supposed to be looking at. Hold on.
I will say thank you to everyone for submitting your contest entries.
And thanks everyone for just tuning in and Marsing out with us.
Yeah.
And thank you to our presenters, Irene, Micah, and Dan again. Please thank them in the chat.
Yeah, we have a lot of congratulations and thanks. And I think some of that was congratulations to Corey. Thanks everyone for the presenting. Brian, you're up.
Yep. Sorry.
Disavon? Is it Disavon?
I had a conflicted version in Dropbox and opened the wrong one because we're editing during the event here. So these are the three that I would put up for contention, and I would like to hear Micah and Dan's reactions to the rowboat, the Marvin, and the There were about 15 others, and they were all, every single one of them was fantastic. Man. These were my personal favorites, and I'd like to hear what you all think.
I'm partial to Marvin because I was actually just looking up the was it the Spirit or the Opportunity mission patch? Had Marvin on him.
That's fantastic.
Yeah.
That's great.
Yeah, I was going to say the same thing. I think Marvin is awesome.
I have to say that was my favorite as well. So congratulations, Kat.
It pleases me.
Can we give Corey a shout out for acronyming her name also?
Yeah, I was going to say, like when you were reading out her name, Corey.
Yeah, no. This was a fantastic list of submissions. Corey acronyming her own name.
Way to combo the games, Corey.
The Marvin acronym winner. The special shout out to Rowboat 2, though. That is fantastic. Possibly more appropriate on Titan, Jupiter. Sorry, no, a Saturn moon. I'm sorry, I've had a few drinks here. That has some lakes on it, and we will need a rowboat or a submarine at some point. But
maybe a Firefly.
And Firefly as well, yeah. So thank you everyone so much. Winners, Corey and Kat, I'll be in touch to send you a little prize. Kat, for a second prize because I owe you one from the last time as well. Thank you, Mars. Thank you, Micah. Thank you, Dan. Thank you, Irene. I am Brian Levine. It is wonderful to see you all, and have a wonderful night.
Night, everyone. Bye.
It pleases me.